So last couple days in class we've been talking about rates and unit rates. And a unit rate we've been working on at getting down to just one unit and figuring out the comparison there. Well, a great real-life application is going to the store and buying different grocery products, because on the labels at the grocery store, most of the time, if we go to like Walmart or Jewel, they tell us what the price is per unit. All right, maybe it's per ounce or per package or things like that. So here's a question right here that works on it. We call this better buy. All right, so you might see your students working on a better buy problem. So we have two things that we can buy. We can either buy a 16 ounce, and let's zoom in a little bit here, it's a little blurry. We could buy a 16 ounce bag of Skittles for $2.08. Or we could buy a 12 ounce bag of Skittles for $1.80. All right, so the very first thing that we need to do, since we're talking about two different packages here, one that's 16, one that's 12, is we need to write two different ratio tables. All right. So, and previous lessons, all I've explained is a ratio table is taking place of what we used to call proportions. All right. And no more are we, saying this over that equals X over a number, because we haven't gotten into algebra yet. And that's kind of important, because if the students don't know how to do algebra yet, they're not going to really succeed with doing proportions. So a ratio table, it's essentially the same thing, but it does help organize a student's thoughts that a little better when they haven't worked with algebra yet. So I look at the two things I'm talking about. We're talking about ounces and money. And the way I explained this to my kids was money gets us to the top. If we look at any successful person, they have money. If we look at the president, he has money. If we look at Bill Gates, he has money. The late Steve Jobs, he had money. All right, money gets you to the top. All right, it makes it easier when we're working in our ratio table. So we want to put money on top, which leaves ounces on the bottom. All right, and my starting ratio here is going to be $2.08. And 16 ounces on top. On the bottom, it was $1.80 for 12 ounces. And kind of like what I said before, we want to figure out the price per unit. Well, what's our unit here? It's ounces. Because I can't really compare. It's not fair to compare 12 ounces and 16 ounces. I want to figure out the price per ounce, which is per 1. And I put a 1 down there. And now this is just solving our ratio table. I have a blank spot up there. So how do I get to this 1 down here? Well, since 16 is on bottom, I have to ask myself, how do I get from 16 down to 1? And we're going down, so it's going to be dividing. 16 divided by 16 gives me 1. Well, what I do to the bottom, I have to do to the top. $2.08 divided by 16, it should give me 0.13. or 13 cents. And I'll highlight that there so that we can see it a little better. Okay. And now on the bottom here, we do the exact same thing. How do I get from 12 down to 1? Well, I'm going to divide by 12 and divide by 12. All right. And $1.80 divided by 12 gives me 0.15, which is 15 cents. Let's fix my 5 there. Looks a little sloppy. There we go. All right, I'm going to highlight that one now so that I know that's the number I'm working with. And now I have to figure out, what is the better buy? So I'm buying the same exact thing. They're both Skittles. Just one bag, is bigger. Well, in here I'm paying 13 cents per ounce. Here I'm paying 15 cents per ounce. So in this case, I'm going to go with the cheaper per ounce, which is going to be my 16 ounce. So I write better buy. I'm just going to circle it, and we are finished.